ladies and gentlemen. Hello, and welcome back once again to the briefing room. My name is Eric Cavanaugh. I will be your moderator for today's event, in which we are going to explore some really interesting technology, folks. Things are changing out there in the world of information systems, and we're going to focus on one of the more revolutionary approaches that we've come across here at the Bloor Group and in the briefing room. So the topic is real-time analytics for a smart enterprise. We're going to be talking about how a variety of innovations are conferring or creating sort of a confluence to fundamentally change the way that information is processed and used, as well as things like business rules and policies and governance. And we'll talk a bit about how you can take advantage of some of this stuff. So here is a slide about yours truly, and enough about me. The mission, as many of you now know in the briefing room, is to reveal the essential characteristics of enterprise software. As many of you know, if you're going out there to buy some new piece of enterprise technology, it's typically not cheap, so you want to make sure you are getting exactly what you think you're getting, and you want to make sure that what you're getting can do the job. So that's one reason why we cover a different topic each month in the briefing room. So the topic of this month is integration. And the angle on integration comes from different perspectives, I suppose. In other words, you can do integration different ways. You can do data integration with things like ETL. You can do data virtualization as a way to get data where it needs to go. You can do application integration, for example, to actually tie together different applications. And of course, through that thing called the service-oriented architecture, or SOA, as some people call it, you wind up with this loose coupling of objects, basically. And usually the SOA is about, of course, services. Now, as many of you know, Dr. Robin Bloor, who will be our analyst today, did a whole research series on the information-oriented architecture, so the IOA, because really a lot of people will tell you that data was kind of the red-headed stepchild in the SOA paradigm. It was almost as if people forgot about data and the importance of making sure that data is the lifeblood that gets to where it needs to go. But certainly, even though SOA did not take over the world, there are many legacies of the service-oriented architecture, in particular service enablement. And then if you look at the web, and we have this concept of a REST-based architecture as opposed, for example, to SOAP, Simple Object Access Protocol, which back in the early days of SOA, everyone was told you have to use WSDL, WSDL, and SOAP, and so forth. And a lot of organizations in the recent past have been using REST, R-E-S-T, as opposed to SOAP. We're going to learn what that means. And of course, the Internet itself is a RESTful architecture, meaning all this stuff is sitting out there waiting for you to use it. So now we're seeing an increasing use of the cloud, for example, not just for data storing, but also for processing. Software as a service, for example, infrastructure as a service, platform as a service. We're starting to see a lot of activity along those lines. And what we'll talk about today is kind of an interesting take that fuses together a lot of these different disciplines or ideas. And as Dave Duggal of Ideate will tell you, he views it as sort of a deconstruction of what's going on. It's a very interesting concept. I actually studied deconstruction many years ago, and I guess if you apply it to the world of information systems today, what it tells you is to really take a close look at what you consider structure and to try to sort of unthread that, to kind of take down the walls and look at things in a different way. That's the essence of deconstruction philosophically, is to try to identify the wireframe in your mind, in your perception, and let it dissolve into everything around it such that you can get more of an open-minded picture of what's happening. Because a lot of times we have a very hardwired view of how things work, and that's certainly the case with information systems. When you do hand coding, for example, to do application integration, when you do ETL, these are very hard-coded, if you will, processes that are little bits and pieces of the overall picture. And what we're talking about today is a way to theoretically deconstruct a lot of that, look down to sort of first principles, or look at the different objects and the things like business rules and policies and of course analytics and different components of an information architecture. Look at them all in more of a fluid fashion such that you can leverage these things in real time and, for example, do real-time process change with analytics. It's pretty cutting-edge stuff. It's pretty interesting. So analyst today is going to be Robin Bloor, of course, Chief Analyst at the Bloor Group. Ideate. Consilience International, I believe, is the company name. At its core, there's a patented Ideate Framework, a real-time application integration platform. You can see the framework offers flexible integration of both analytics and transaction processing. So we're kind of crossing some wires here and fusing, and a hummingbird just flew past my window, folks. Ideate leverages mass customization to weave together data, processes, and policies in real time. So this is pretty interesting stuff that we've got out here. So there's Dave Duggal. He's the co-founder and managing director of Consilience International. And I'm going to go ahead and push Dave's first slide. I'm going to hand the keys to the WebEx to him. And with that, Dave, the floor is yours.
Great. Hey, Eric. Thank you very much. I appreciate it. And I appreciate everybody setting aside some time for me today. Well, Enterprise Web is something, we're sort of premiering this new branding here on your show. So this is a special sneak preview for your regular attendees here, Eric. But the Enterprise Web is a concept that we've taken to bring the power of web-style architecture to the enterprise, right? Everybody's familiar, as you mentioned, with SOA and service orientation and the idea of breaking functions down from big applications, big black boxes, into what are essentially smaller black boxes, and share those between applications. But as you mentioned, and Robin has reported in the IOA, Information-Oriented Architecture research, SOA is not an information system, right? It's a method for exchanging functions between third-party systems. And at that, it does a great job. But when we're really talking about composite apps and the increasing demands on composite apps, I think we have to look beyond conventional definitions of SOA and be inclusive of REST concepts, or REST being representational state transfer, or it's essentially the definition of the architectural style that underlies the web. And, I'd like to not be so technical and wonky. Let's just put this from the business perspective for a second here. Everybody pretty much loves the web. I don't think I've ever met anybody who didn't like the web, right? As far as they're concerned, the web is fast, it's responsive, it's scalable, interactive. It's got all these qualities that people like, but you rarely hear those things applied to enterprise software applications, right? There's a little bit of a divide. In fact, I'd say it's a growing chasm between people, partners, customers, and their desire to interact with systems that respond to their needs, and what current enterprise application architecture is doing for them. So we've taken web-style architecture, which is a great document architecture, a great architecture for sharing information, and we've applied it to the problems of enterprise software applications, and in a way that works seamlessly with existing APIs and service orientation. So it's really an extension to help people, advance, help with application modernization. So I'm going to start pushing my slides now. Let's use the extended intro here and see if, okay, great. So the Enterprise Web, it's an application platform, as I mentioned, based on web-style architecture. It supports event-driven processes. And what's important here is that while event-driven architectures have been around for a while, they've been mostly limited implementations for specific purposes that are coded in advance, so as opposed to enterprise-wide process architecture. And what we're doing is we're making event-driven architecture, real-time business processes. We're making it practical, governable, scalable for every organization, not just the Fortune 500, but any organization can use this. And of course, the Fortune 500, everybody's trying to save money now, so everybody would like more scalability with less hardware and less software. And so those are the kind of problem spaces we're addressing. So part of being event-driven, it allows us to take real-time business intelligence and predictive analytics and compute that analytics and business intelligence as part of deriving or returning a customer response to the business users, so that BI and predictive analytics can inform business processes. So business users are getting the latest information, that they're getting informed based on other things happening in the enterprise. It could anything from the performance of various services and whether a service is performing slowly and therefore they get redirected, or whether it's recommendations. And people are familiar with those kind of things in one-off applications like Netflix and other web-based applications, but they don't really see that yet in their enterprise applications. The system is based and built on top of a unified repository. You could think of it as an intelligent data warehouse or a virtual data warehouse. But what distinguishes us is that we've taken one unified approach to storing code, data, user interface artifacts, as well as services and APIs. So all application resources and business objects can reside, at least virtually, in one location. And that creates this enterprise web of linked and indexed information. Since we use a web-style architecture, it's very lightweight, scalable. It's also multi-tenant. And the platform can be deployed in a variety of formats, on-premise, cloud, and hybrid. To summarize, we really are a breakthrough in application architecture, and that might be a little bit of hubris for me to say that. But I think, as Hadoop and MapReduce are to making big data analytics practical for virtually any size organization, though I'd submit it's still difficult for most organizations because it's highly technical implementations, we are making real-time business process cost-effective and scalable for any operation. So in that regard, it really is a break from the past of traditional business process technologies. The technology is ideal for, knowledge work type applications that are highly human-centered. Sometimes that's referred to as adaptive business processes or adaptive case management. So the system is really good at working with processes that revolve around human discretion, human intervention, and events, so that people can control their processes, that they can modify their processes in flight, that they can include and exclude certain capabilities and information to cater the process so it's tailored to their specific requirements of their circumstances. And that's all done within permission, so it's not the absence of governance. What it is it's the opportunity for flexibility. So, I typically like to say as flexible as possible, as procedural as necessary. I think most people are very familiar with processes that seem very rigid and inflexible to their needs. And whenever we run into a process like that, it always seems very bureaucratic and causes a lot of frustration. But it's not only frustration that it's causing, it's potentially causing lost business value, and it certainly results in shadow systems, because what our enterprise systems can't do, we of course then translate into emails and Excel spreadsheets, which makes the whole process of change management harder. So we're really good and well designed for this growing area of need for adaptive business processes and case management. Also, the architecture that we have really allows us to look across all processes that are running or applications that are running and do sort of GRC, classic GRC type applications. Again, those are usually one-off applications that are hard-coded or specialized pieces of middleware that have to be maintained separately. And what we do is we give you an environment where it's easy, very easy for you to govern and inspect all processes that are running and look for things like fraud detection, look for things like conflict of interest, et cetera, so that you can not only run really adaptive processes, you can actually monitor those processes and dynamically, interject new rules and maybe potentially new process steps into those processes to make sure that you're compliant. And the one last thing, which is sort of an edge use case, but you're hearing more and more about it nowadays, is sensor networks and the Internet of Things. The ability to manage devices, whether it's cell phone towers, whether it's devices inside your house, managing those remotely, and interconnect sensors in different applications through a web that connects them to human-centered processes. So you can imagine if you have a device that breaks down, some sort of waste station, some sort of electric utility pole or service station has a problem, the system can actually detect those problems on demand. It can actually automatically look for service representatives in the area. It can actually look at which of those is available and has the skills and route the appropriate person to service that specific device. So that's, again, an edge use case, but you're hearing more and more about that need. So moving along. We, as a company, we're only 3 years old, but we actually already have customers in North America, Europe, the Middle East, Australia, New Zealand, and our latest is a proof of concept for a South American bank. So things are getting pretty exciting for us. We have customers. All of our customers are enterprise customers, So we're talking about tens of thousands of named users, thousands of active users, hundreds of thousands of records, and active everyday use. And as opposed to selling people one-off applications, we're really selling a platform, and we sell it at an enterprise license, so they're not feeling like they're nickeled and dimed every time they want to add a new business user, or they want to add a new application or process to the system. So while I know those things are sort of trendy for cloud applications, we're looking at really serious enterprise requirements and saying and looking at and coming up with the conclusion that enterprises really don't want to be paying per drink all the time. That's very unpredictable. It's hard to budget. Even think of our, most people now have unlimited phone calls in their house at this point, right? That's a much better situation than paying for every long-distance phone call. I remember when it used to be expensive to call, for more than 5 minutes to California from New York. I much appreciate that I pay one flat fee now and I can call anywhere I want for as long as I want. And I think that's going to ultimately hit the cloud market as well as, the enterprise software market in general. So in addition to selling the product directly, we also have partners in the UK, and we're also co-developing apps with domain experts. One is a well-known enterprise architect, Roger Sessions. He has a patented methodology for managing project risk, and we've done a really interesting application for him. We developed it in under 5 days, and it's now being tested in the United States and South America with banks for managing large-scale risk on software projects. Most people are aware that software projects, have a high failure rate, and particularly projects over $1 million. Big organizations like banks do, 20, 30, 40, $50 million software projects and above, and so managing risk is really important to them. So now we've provided a methodology that, tracks, various risk factors and makes that accessible to business users and executives so that they can better manage their projects. So, what's really the problem that we're addressing? I mean, the real problem, as I think this, cartoon really well aptly illustrates, is that, IT is constantly rolling this rock uphill, and the rules of the game are constantly changing on them, right? The business looks like it's an impediment for IT going forward. And really what that is that, we get this notion sometimes that everything would be great if we could just finish the model. But the real world is, cannot be completely modeled because it's dynamic. It's changing all the time. So we really need to move to an adaptive software paradigm where the architecture is adaptive and the processes are adaptive so that they can support runtime variance and they can support change without breaking. 30 years into, 30, 40 plus years into the software era and the era of automation, and the least automated, the least efficient part of the enterprise is arguably change management. So, and every business user has that frustration, right? You run into a problem, who do you call? You call IT. Of course, they're overwhelmed solving a lot of other problems, no fault of their own, but they're trying to perfect everybody's models, and all those models are evolving all the time. And so it ends up going into a suggestion box of a sort, and, good luck waiting for that. And by the time it's ultimately done, your requirements might have further evolved. So this is the fundamental conundrum of enterprise IT. And, usually this is resolved in, the classic 3-tier application and, a nice, simple self-contained box. This is sort of the traditional siloed app, right? It's got its own user interface, its own business logic, and its own connections to a database, and traditionally just one, right? But the real world today, we're looking at something much more complex, right? We're looking at, diverse and distributed sources. We're not just talking about connecting to one database. We're connecting to multiple databases. Maybe sensors are providing information. Maybe we're drawing information from public databases. Plus, we might have business entities, master data that we want to use. And we've got to manage all of those inputs. And in addition, we have distributed and diverse targets, right? We've got to deliver these to browsers, iPhones, smartphones of various sorts, and maybe to other cloud applications or applications running somewhere else. So we really very quickly realized that we got to have a very strong, thin middle tier that takes data from virtually any source, regardless of its structure, regardless of where it resides, and can process it dynamically to deliver to a business user in a very contextualized way for their current interaction on the device that they want to use. And, that's no small order. People have been looking into these problems for distributed computing for a long time. And I think what we're bringing in and introducing to this market, this fusion of web-style architecture and service-oriented principles, I think just gives people a path forward to get that, that kind of high-speed processing and flexibility they want. So, to give an architectural diagram that will probably be familiar to many people, is, you got your traditional stack here, and you can see there's the middleware. And, of course, on the cloud, we represent that middleware as a service. And you can see, really, the cloud in that regard is not really representing much of a change. You just tack on as a service to any piece of existing middleware, and, you're just representing the same old middleware stacks, and you're now just doing them on a distributed basis on hosted environments. Of course, the cloud introduces some other challenges there because now that's not within your firewall, or it's outside of your firewall, and you have some extra challenges in regards to integration and interoperability across potentially different pieces of middleware or platforms as a service, as it were, that are also distributed. Whereas in the on-premise approach, you had this all at least under your control. Now these are all diverse, discrete pieces of technology, maybe hosted by third parties with different SLAs running on different kinds of environments in different parts of the world. And that introduces some new challenges. And what we offer is a model that works for on-premise and the cloud. And it's a unified processing platform, one single processing engine, one single processing model that supports events, analytics, processes, rules, integration, and application modeling all in one. And the advantage of that is it's one thin layer, it's extensible, it can do all of these things in a single cycle to provide very rich transactions. And it can work across a shared state space so that it can actually go out and review analyze a bigger pool of information than a normal application would. It minimizes latency, improves application dynamics, and horizontal scalability. So this approach has many different virtues. As time allows, we're going to do a demonstration as well. So what does that look like? Drilling into that a little bit deeper, we can see, back to that three-tier view of the world. From any to any presentation tier, really right? And from any data tier, whether we're connecting things with RESTful services APIs, whether it's with OAuth or, just a regular plain RESTful service, whether it's a SOAP service with a WSDL, a custom, JavaScript integration, or maybe some stream harvesting, it really doesn't matter. We have to be able to take information from any source, store it, and then run processes, events, rules, apply security, provide concepts of portal, all in one thin layer to get the maximum return for that business user. So moving on. So, what does this look like? And this becomes sort of a nice conceptual diagram, is we have this notion of this enterprise web, right? And in a web, everything is linked and indexed, right? We find things by navigating through links, or we find things by doing searches, whether you use Google or some other search mechanism. Everybody's very familiar with those capabilities. We're applying those capabilities inside our system to not just to data, but to all data, code, rules, user interface information, adapters for third-party APIs and services. So in other words, we create effectively an enterprise internal warehouse, virtual warehouse of all of this information, which is all referenced by links and it's all indexed, so that we can search and do queries against this environment very quickly without any of the typical latency that you would have across multiple pieces of middleware that you would have with rigid ERDs, the kind of complex joins you would have in an environment with, navigating, SQL statements across, rigid ERDs. You're effectively talking about a schemaless enterprise application environment. And that allows us to move through this environment very quickly and do, millisecond response times, which you couldn't do otherwise. So unified process architecture, I mean, historically processes were their own application silos, right? Each process has its own connections to services and data, has its own forms and other UI and rules and logic built into that process. Here, all processes are drawing from and feeding back to a common pool of information. So a unified process architecture. This nets us a lot of capabilities. It, liberates the information from process silos. That means that information can be shared seamlessly across processes. That's something very hard to do in applications traditionally. In our system, it's very easy to do. So processes can be signaling each other very readily. It also means that there, like I mentioned before, there's no joins. So it's very easy to correlate information, system-wide activity, not just information related to a process that might be pre-compiled or pre-organized in some fashion, but actually to run real-time queries and correlate information to compute aggregates at runtime for up-to-the-minute information, for up-to-the-minute feedback, recommendations, guidance, precision-based policies, et cetera. So much more highly targeted event-based processes. This, lets us operationalize business intelligence and predictive analytics in a way that it's never been done before, right? Typically you run your BI and analytics off one set or multiple sets of discrete, data warehouses and cubes, et cetera, which all have their own dedicated connections to data, et cetera. And business processes run off completely different environments. So you have this big disjoint. Eric, in the setup for this presentation, talked about, analytics versus processes and transactions, that historic divide between OLAP, or online analytics processing, versus online transaction processing, OLTP. And we're crossing that divide by providing this one environment. And it's extensible, right? So it's not just an environment for things that natively reside inside, but it can also have adapters for these third-party things. So clearly, it's not just for greenfields applications. It supports your, extensions of your legacy apps. It supports your existing libraries of services. It's extensible to third-party APIs, et cetera. As I mentioned, it supports interdependent processes. And it, I was talking about GRC apps before, as far as being applications that it's well targeted for. It actually supports cross-process governance, right? I mentioned fraud detections, conflict of interest, policy compliance. It could also be doing things like system monitoring, server utilization, sensor management. We could be rerouting, do dynamic things with load balancing, et cetera, because there's nothing beyond the system's ability to reason on, right? It could be reasoning on, hey, this service is slow. There's another service that's been provided that replicates that capability off a different server. Go, call that service. It could be looking at, partitions of the information and reallocating as necessary. A system that allows processes to be interdependent in a way that conventional business process management technologies can't do, and also supports cross-process governance in a way that most conventional business process technologies don't allow you to do. So we're really this hybrid of an information warehouse, a data warehouse of some form, an application repository, some sort of enterprise-centric GitHub, with integrated transaction environment on top of it that supports these highly dynamic processes. So that's the end of the slides. And Eric, I don't know if you want, we can segue to the demo. I know Robin probably has some questions.
Yeah, let's get Robin to do his slides, and I'm going to push the first slide here. And Robin, I'm going to hand the keys over to you, and then when we get into the Q&A, you can launch as you're answering some questions and show people how it works. Robin, the floor is yours.
Okay, thanks for that. Oh, look, there's a picture of me. Right, what I thought I'd do for this, I mean, I've kind of had a briefing on Ideate, must have been about a year ago, so I've got much more stronger understanding of what's going on underneath than Dave has given you from the presentation. I think Dave attacked it at the business layer in terms of the proposition. But anyway, I thought I'd tell an architecture story. I mean, basically architecture is a kind of an interesting thing in terms of software. If you came into the business early enough, which is a very long time ago, there wasn't such a thing as architecture. It was just kind of getting by and building things. If there was anything that you thought of in terms of architecture, I mean, you was creating modules. So, breaking down what were complex processes into a set of simple processes, which was module calling, module calling, module. So, why do we have software architecture now? Well, the obvious answer is because we have such big environments. It's like you didn't need an architect to design a TP, but as soon as you started building bungalows, it came maybe a good idea to have plans, and then when you started building up to skyscrapers, you did need an architect. So with software, we're talking about, in terms of architecture, we're talking about the effective distribution of software and data across distributed resources. And the less distributed the resources we have, the less need there was to have anything that was particularly architectural in the way that you actually wrote applications. The fundamental, the way that software architecture grew up, and it's exhibited in Dave's slide. I would have sort of talked about it in a different way, but I'm not talking about his product. I'm just talking generally. The first thing that I was taught, although it has to be said, an awful lot of people were never taught this that actually went on to be programmers. But I was taught that there should be a separation of concerns. And that idea, I eventually discovered, dated back to the anti-Spark architecture for databases that was originally proposed in 1975. And that was the idea that there should be three layers to a database user interface, a processing layer and a data access layer. That idea was later generalized so that to the idea of, well, there's a concern of user interface, relevant to what happens with the data. A user's got to interact with a computer. Then there's the logic of what an application is doing, which sits in the middle, and then there's data logic because, you want some of the data to persist. You have to put it away, possibly not in the form in which you used it, or maybe in the form in which you used it, but there's some logic to putting the data away. But this triple layer is also, in some way or other, it's meshed in with the fact that there's logical activity and physical activity. And logical activity is what the application is doing, and physical activity is the computer making or allowing the application to do that, probably making it do it. Physical layer is pretty much all about performance. So there was always two layers within this kind of triple layer look at things. And the goal is for the independence or the non-mingling of processes that have different goals, because if they get mingled up, then you change one and you can affect the other. And that's just, that's just what we learned over many, many years. So, if I kind of represent kind of what I've said, we have this presentation logic, business logic, data logic down one side of the diagram here, and we look at the world as we kind of see it, and we have a presentation layer that turns out to be incredibly complicated. I mean, we have multiple devices out there. We have not just, that an application presents itself, it might be presenting itself through a portal. There's also the possibility of voice interfaces. There's possibility of just about any kind of interface you can think of. So the presentation layer itself can be very complicated and can be very diverse. And then we've got the advent of SOA, which created, this business logic layer where one application would call the capability of another application, and that call the capability of another, and so on and so forth. It started off as the AI, then it ended up as SOA. And SOA is the kind of thing that Dave's talking about, although if I understand it correctly, then Ideate is like SOA in the sense that you can mash up things together to get stuff to happen, but it's not like SOA in terms of the way it handles integration. If I understand it correctly, Ideate has got a more elegant way of integrating things together. And then there's the data layer integration that actually Eric mentioned. And just in the data layer integration, it's the only reason I've put the information or the architecture up. If you just look at the data layer, so you're just looking at BI applications and everything that goes to support that. You see, there's just a massive amount of distribution going on, and right there in yellow, you've got a whole bunch of middleware that in one way or another is doing stuff. Some of that middleware is doing stuff just in a way to connect one thing to another in a reliable way. Some of it's doing stuff that actually has to be done, like data quality, which is a rules issue. And there are other things. There's the management of the metadata, all of that, and metadata management. There's whole rules that apply to governance. There's a whole lot of things that can be going on. There can be performance engines, is what you get with data virtualization. And that's not all of it, because you've got a whole set of software development activity that goes on to feed this kind of huge environment. Well, if I understand it correctly, and that's what I'd kind of like to discuss with Dave, if I understand correctly, what Ideate is doing is circumventing or making unnecessary a good amount of this. Not all of it, I don't think, but I can be corrected by Dave if I'm wrong. So just kind of a summary on software architecture to show what happened, historically. I mean, first of all, we had the centralized mainframe architecture, and that was kind of free schema in a way. We did have a user interface. We did have processing logic in the middle, and we did have data at the bottom. Pretty much got thinned out in terms of client-server, where everything's split in two. And then we got this just breaking up into tier after tier after tier, the three-tier architecture, multi-tier architectures, multi-layered and multi-tiered architectures, which is effectively what happened with SOA. You could have many, many things connecting to each other in order to deliver an application, or actually a whole business process if you wanted to put workflow into that. And then at the bottom of this, as soon as you go outside the organization, you're actually stuck with a web architecture. We're not going to get away from that. And we've seen the extraordinary expansion of the cloud, and the cloud has web architecture written all over it. So, in terms of software architectures, we've gone from something fairly simple to something which is extraordinarily complex, which actually, if you take the web as a whole, there are millions of possible executables out there, or possible services, or possible pieces of data you might want to get at. And we need, and one of the things that's causing problems in the world, but we need an architecture that will make that a lot more accessible than it is, would be a good thing. So, Dave, if you're going to do a demo, then I'm just going to start asking you questions, and if you can think of a point at which it would be a good idea to go to a demo, then just say, okay. But, I mean, the first thing that I wanted you to try and qualify is, what's the full area of applications? You mentioned that, yes, it can do BI, or it can be useful in BI context. It can be useful in a transactional processing context. So what wouldn't you use it for? What areas are so specialized that the application environment that you've got really wouldn't hack it?
Yeah, that's a great question. I mean, I think the focus of the Ideate Framework, or I don't think, the focus of the Ideate Framework is process, right? Doing smart connected processes. So it's under that context that it manages all those, diverse activities that you have, nicely laid out in your information-oriented architecture diagram. So it's really focused on process, doing analytics and BI for process, feeding back information for processes, connecting devices and databases for processes, et cetera. So in that case, this is an extension, a very direct extension of business process technology. However, if you were to try to emulate what we do in a conventional middleware approach, you'd very quickly have a stack, which by virtue of that stack, it would make you less agile and flexible and adaptive than our single layer approach. So if we were to try and do what we do in middleware, you'd have an event processing capability, you'd have business rules capabilities, middleware, you would have process middleware. In BPMN, if it was business process management notation, you'd also have the execution side of that, which is BEPL. So you'd have separate software for that. You would have software for analytics and BI that would be discrete, and you'd actually have separate repositories for managing the information, because business process technology in and of itself doesn't manage data. It just manages process variables. So you'd actually, and that's just to name a few, to be honest, and those are, I think, all show up on your IOA diagram. So what we're really trying to do is get that mundane middleware out of the middle, right? Because if you think of it, middleware is aptly named. It's what's between me and what I want to do, right? Middleware is between me and the information and capabilities I want to have. And the primary way that businesses deliver value is through processes, right? We use business processes, both human and system, and combination of human and system processes to transform information and capabilities to deliver business value. So what we're trying to do is take out or help enterprises consolidate that sort of core stack so that they have a nice unified environment, a simplified processing model. That simplified processing model actually liberates their data and code and helps them be more flexible and agile. If I were to do something and I need to make changes in a business process management type technology, changing the flow chart does not change my reality, right? Because, well, that flow chart might be connected to a business rule. Now I go change that business rule, and that might be connected to data, and I go change the data. So you have all these nested dependencies and all this state information trapped in that middleware. So we're trying to get to that. I'm sorry if that was if I ran long there.
That's okay. There's the next two questions are kind of one question, really. I kind of know how it integrates with cloud applications. You kind of said, it's got RESTful interfaces. It can go and grab anything out there in the cloud. But when I think about the cloud, especially when I think about a cloud environment where you might be connecting to 4 or 5 different things and expecting them to work well together. The thing that makes me nervous is just the idea of a failure. When you're in a data center, whatever the situation, actually, no matter how badly constructed the software, you can normally go into a recovery situation fairly swiftly. So what I kind of wanted you to speak to is what kind of recovery architecture or engineering lies underneath Ideate?
Well, the whole system is, built on, web-style architecture and functional programming ideas, right? So functional programming has been with us for a really long time. It's never really made it mainstream because it's a very, it's a very math-intensive approach to computation, but it gives a lot of flexibility and adaptability. Both of those have tremendous amounts of resilience in them, right? So, first of all, Robin, you've never broken the web, right? Nor has Eric, or Rebecca or Mary Jo. Nobody we know actually has been responsible for breaking the web for some use that they had, right? Your internet connection might go down, but we don't break the web. It's hard to break an architecture that's just made out of things, loosely coupled things, right? Everything here is loosely coupled, right? So things aren't breaking as systems; they're just things, right? So things might not be present, right? So it's very resilient in the way that the web is resilient. It's also resilient in the way functional programming is resilient, because functional programming has these ideas of immutability of code, referential integrity. So, the system actually provides for temporal notions that traditional relational databases don't support. It's associative, so it supports, flexible relationships in a way that traditional SQL relational databases don't support. So it's really, it's actually a very stable platform. I hesitate to say this on an open mic, but we haven't broken down in 18 months. We haven't had a single customer have a single crash in 18 months. And I'm not sure if virtually any vendor in the world can say likewise for something that's deployed locally that is integrated to a variety of other technologies, et cetera. So it doesn't crash. It's more like the web. If something's missing, but the app won't break, the framework won't break, the system won't go down, just maybe something on that page won't work, and it will make itself evident as well.
Okay, that's interesting.
So we're prone to fail safe. Failures happen, but fail safe is, I think, the big thing that you want to do in software.
Okay, and maybe this is a good, in the light of this question, but the thing that I was kind of looking at the presentation, I was thinking, okay, you're integrating together a population of resources out there, and you can get at data in one way or another. You can get at executables in one way or another. You can define rules and have the rules proliferate and so on and so forth. But let's imagine that I just want to say I'm an organization and there's an application I don't have, and I've got Ideate, and maybe I just want to build a new application. So how would that kind of work? Would I need to, for instance, you better go and get yourself a database and have to define the database myself through a schema? I mean, how would you go about it? And in explaining that, maybe you can actually just do a demo of how it works on something that you've got, one you built earlier.
Actually, yeah, I can do that. I'll switch over. I'll answer it really briefly, and then I'll switch into product. So the system has its own modeling environment, and since it's a sort of unified, integrated space, right, it has the virtual repository, a web-style repository of data, code, UI, services, and APIs, all stored as documents, or in the parlance of the web or REST, we call those resources, right, which is just information with links on them or URIs. And in its index. So the system indexes everything all the time, so as things are added or changed. So the system has a very small footprint. It deploys on any virtual or dedicated environment. We can push it over the web in under 30 minutes to run locally on somebody's environment, and it's fully working. All of its applications are running. All of its resources are available. It's inspectable in under 30 minutes. And it can run on commodity boxes, so it deploys very quickly. It has its own modeling environment and rich libraries of pre-existing capabilities, like we support iPhone, iOS. We support connections to Twitter, LinkedIn, a variety of connections. We connect to different systems, et cetera. So LDAP, Active Directory, et cetera. We work integrating people with their enterprise financial systems. So all sorts of connectors. And because everything binds late in our system, they're very flexibly reusable. So we separate out this notion of integration from interoperability or binding, right? Since we have a loosely coupled environment, our system binds everything at runtime, so it makes sense of the world. It's an event, right? Every time there's an interaction, it's an event. It actually analyzes that event against rules, finds the appropriate resources, which could be, that processing could be extended by including predictive analytics or BI queries to find things that might be referenced through links and metadata, then to compute a customized response for that business user, to recommend next best actions, and it all does all of that in a millisecond. So the system gives you pretty much everything you need to build apps, and it's very easy to deploy. And maybe it is best, this being abstract, maybe it's best if I just pop into the product for a little bit and show a demo.
Yeah, I think so.
All right, great. All right, so I'll see through the magic. Eric trained me well, and see if I can get to my system. Great. So I think you should be seeing my environment.
Yep, looks good.
Fantastic. Okay, great. So we're in a web-based portal, and our system, everything is generated in real time in our system. So this portal is a representation. It's an out-of-the-box portal representation, but this could integrate with customers' existing portal technologies. So we're not telling people to get rid of what they have, right? And people, of course, have very specialized tools and legacy tools that are deeply implemented. They're not getting rid of those. What we're really trying to do is give a flexible environment where they can combine those different assets and resources in flexible new ways to provide more meaningful results to business users. So as I move through this environment, every click in the system the UI is being derived at runtime. This would be the same if I was interacting through iPhone or any other interface. So this portal features prominently enterprise search. We call this the live list. And what's neat about our live list concept, it's universal across our system, and it's all filtered. My name is Dave, but I'm logged in as Bill Malik. And Bill Malik has certain rights to access certain kinds of records. In this particular environment, he can find people's profiles, he can find information related to budgets, he can find projects, casework that he was working on, and he can search that very flexibly. And what's really neat about this is if I go into another environment, go into Bill where he has other permissions, And so I'm just toggling between environments right now. And in this environment, Bill is a developer, and he has access to application resources. So at a glance, he can find any piece of code, data, UI information, service. He could search that if he wants to find the Twitter service. Boom, there's the Twitter service, right? And I'm doing this live over the web, actually, so this is not running on my desktop. I'm in upstate New York. This is running out of believe it or not, it's running off a box in Toronto, Canada. And you'll see everything is in real time. But this is nice because we create utilities that are shared or universal across our entire platform. So enterprise search just comes with our system because by virtue of everything being indexed, we make it very easy for people to find things. And, when I go around, I find out that, talking to people, that people spend a third to half of their time, busy, business users and administrators and developers, just finding things, finding the state of things. What's the status on this? Who has it? Where is it in its progress? Has it been updated? And so we're trying to give people self-help models, so not only using this sort of real-time event-driven technology for the business processes, but also, materializing that through enterprise search. So if I want to find everything in this environment, happens to be an environment dedicated to researchers for cancer, I can go into something, find something for cancer very quickly, and at a glance I have every piece of information about it. Now, this portal in and of itself doesn't look particularly novel, right? It's how it's doing what it does and what capabilities I get from that. So a couple of things I want to point out right away that are interesting is not only can I see sort of conventional tabs that describe components of this particular record, which happens to be a research project on blood cancer, is I can actually click on this at a glance and I can see every single person who's ever touched this record. So from a functional programming perspective, this is referential integrity, right? Immutability of code. We actually know every single person who's touched this record. We know everything that's ever changed every time this has changed hands. We can roll back this record to any of those previous statuses. We can not only see the business information as it existed at a moment in time, we actually know which versions of which resources were consumed by a process at any given moment in time. And we make that very easy for people to find and audit. So from a business user perspective or from a corporate executive perspective, this is the ultimate audit control, right? This is real transparency into your processes, what happened. And I'm sure everybody would find advantage in being able to sort of roll back the clock, as it were, to see where a material change might have happened and understand why that change happened the way it did. But we also, it's also useful, of course, for development as well, because we know it's application lifecycle management on the other side of the fence, right? Because we know every time a resource is changed, we're storing the deltas on those resources as well. So everything that we do at the business user side, we also provide to the technical side and vice versa. So the system, this is a very complex record. It has, it's linked, like I mentioned before in my demonstration, in my slides, that you can have records that are linked to other records, and I can actually very quickly get access to those records and see their details. And these records can be signaling each other, so if one is suspended, maybe it suspends the other activity. The system tells me exactly where I am in a process. In this case, in the second period of something that has 4 periods, and it's locking me down to only taking actions against that specific period. So there's a lot of governance in here, right? Because the system knows a lot about this record and all of its associations, it can very narrowly manage me. It can help me, it could draw me to those things where I can work on. It can prevent me from doing things where I shouldn't be doing work right now. It could even be managing things that are maybe done outside of the system, like expenditures. So expenditures in most situations are going to be managed by third-party financial systems, payroll systems, et cetera. But, I can actually wrap processes around those. So I can see the approval processes, who approved this expenditure, what's the status of this expenditure. And then I can go drill into this record, and I can see all of the expenditures against this record, all the monies, what was the budget for this record. Now, this happens to be one kind of record, but lots of different kinds of projects will have costs associated with them. They might not get all of the money that they've requested, so we're storing all of those deltas, and we can even track the expenditures. And because the system has temporal notions, like I mentioned before, we can actually roll back in time, right? So we can go back, and if you notice here, I've wiped out all the expenditures. And I, like a DVD player, I can click here, and you can see that the expenditures are changing as I move through time. So I can actually go back and forward in this record and see this information as it existed, as the budget data existed in different times. Now, most people's financials won't be pushing this to the people and to the business users, but their business users would prize this information. It also gives the business users the ability to look at information from many different perspectives, right? So they can see it all rolled up as a summary. They could see it over just in segments of increments of time. They could see it with increments of time with details. And this kind of flexibility or multi-view just gives the business users power over perspectives, right? It lets them see things from multiple different ways.
Yeah, and Dave, if I could chime in here just for a quick second.
Yep.
I'm wondering, can you show, like we've talked about this sort of real-time analytics, just-in-time binding, if you will. Can you give some kind of example as to how some event or occurrence or change in state, for example, of an object could be mapped to a business rule and then triggered?
Fantastic. And I have a good example. It's obviously a simple one for the time that we have today, so I just wanted to give people a quick orientation. But I'm going to flip into a example of predictive analytics. And this is a very simple one that should be, hopefully very obvious on its face value. And so in this particular environment, Bill is a developer, right? And he might be, it's a real-time environment, and keep in mind, since everything's just done with links and metadata, there's no compile time, no build time, right? If I'm testing something, I could be testing and simulating it in real time. I could be simulating as I go. I don't have to do separate build, compile, update, post kind of things like that. The system allows me to simulate in real time. I could still be doing this in multiple different environments, but there's still some advantages here. So I'm going to give you a pretty extreme example of that. So in this environment, Bill has a record in here that he's created for an application. And in this particular application, it has a predictive analytics. That is a weighted formula in here. And this weighted formula has multiple factors it draws on. It looks at the person who's working on this research. It's going to check their personal profile, and it's going to weight some interests that they have in their personal profile. It's going to cross-reference this very application or this instance or process and look at some keywords that are represented in this particular instance or activity. It's also going to look at the sponsor record. The sponsor is a whole other entity, right, in this enterprise web. So it's looking at three parts, right? It's looking at the application, it's looking at the user's profile, it's looking at the sponsor or this other organization's profile, and it's going to do this weighted predictive analytics to make a recommendation, right? And of course, everybody likes recommendations, and so in this case, it's recommending which funding opportunities a researcher might have the most luck with, and that's a pretty handy capability. And just to show you that that works in real time, if I go in here and I just add another keyword here, and I add statistics to that, it'll automatically update the weighting. So before it was 13% was the highest, and now it's 17%. It's rejiggered these calculations. But let's do something really interesting that shows off how dynamic the system is, both from the development perspective and also to Robin's point about how durable the system is as far as being durable against breakage, how sustainable it is. So I'm going to go back home. I'm going to look up that formula, that analytics that actually runs that particular. So I'm now going in with my developer hat, and I'm looking up a particular application resource, and I'm going to skip very quickly to the analytics part of that. So now I'm going in an application that is like an IDE, but it's really just another application of our system, and it shows me everything that's linked, shows me nice dependency maps here, so I think everything that's associated with this record. I can see all the workflows associated to it, the UIs that are associated to it, and here's a policy that's associated to it, and there's some functions, and this policy has submission probability. And you're going to see this is actually a MapReduce function, and a lot of people talk about Hadoop and MapReduce being very complex. You're going to see that we're doing this very simply. We actually are very concise. At this point, currently it's a JavaScript syntax, but we actually have API helpers that are going to let people do this completely through metadata so that you can actually build out queries completely from metadata that is known to be available for different entities. So you won't have to do it in a technical fashion at all. The idea is that we're going to make this surface so a business user can do it. But right now you can see the subject was funding opportunities, FO, interests, match the PI interests, that's very, very concise, and the funding opportunity interests also match the application interests, and there it's weighting. And it also matches the PI, the person's, the user's success rate against that sponsor. And it has a formula there for computing this. Now that's what's actually currently computing that formula, but let's go break this on purpose. So I'm going to purposely insert something here that I know is going to break the system. And this is going to show you the ability to simulate very quickly, the system's ability to do a manifest and a trace of all issues, and the system's ability to repair very quickly. So now I did something. Now, as many people on this line will be aware, if I make an immaterial change to a service interface, I'd break all related applications immediately, right? Here, I've made a pretty material change. In a service interface, in SOA, I make a very immaterial change, and it could break those applications. Here, I made a very material change. Let's go check out that application again. And so I go back home, and over here, I've been just closing this task panel here. And I click back into that task, the same task we were just in. And now you'll notice with that error, the system detected an error immediately, but it did not break this app, right? The app is not broken. I can continue to click around this application. As a technical person, it's actually surfacing to me the ability to actually trace this issue. And it's actually, obviously, it couldn't fulfill this probability because part of the formula is now broken. But the framework didn't break, the application doesn't break, the instance doesn't break, nothing's broken. And it was self-detected, right? I'm doing this all in real time. I go out now, I click on this, and for, people talk about dynamic systems as being, not governable. I'd submit that this is more governable and more powerful than most static type systems. I'm now looking at a complete manifest of every single thing our system did in trying to compute that interface, right? And now this is, most people, for most interactions, running a single SQL statement can take several milliseconds. Our system is running out, connecting and transforming, in this case, 50-plus resources, mashing them up at runtime, and doing that millisecond time, and it's giving this manifest, which actually shows me where the error happened, right? I click on that. It opens up the development environment because I have those rights. And I can go right in here, right? And this is obviously, I'm just doing this to illustrate it. I save again because I'm actually, now every time I'm changing this record, the system is saving that. Every change to the record, the system is saved. The system knows that I went in with my login and changed this application resource. So all of this is preserved for history. So this can all be rolled back. And now if I refresh the screen, F5, and you'll see that the error is now cleared. And so that gives you an idea of sort of the power, flexibility, stability of the system. You could see how many resources it was actually impacting, all the kind of connections and transformations it was doing to do this. As a business user, not only can a developer could be making fixes like that at runtime, business users could be actually requesting changes. They could actually be adding values on forms. They could actually be manipulating their own processes. Here you notice conveniently, I click open this window, and as a business user, I could actually have the ability to see the process steps in front of me. And I could see that now this one is the next step after I submit it, but I have, based on my rights, the way this application was designed, I have the ability to maybe create my own next step. So business users can participate in the creation and management of their own processes. So this opens the door to runtime adaptation of processes, right? Where processes being manipulated by business users with permissions. Those changes could be subject to their own approval workflows, but it just means that nothing ever gets stuck anymore. Because remember, every time an application breaks, you have a frustrated business user and lost business value. Every time an application doesn't support a current need or business context, the business value is lost, and you're going to have frustrated business users again, and those business users are then going to go out and create shadow systems and do things through email. It's impacting the credibility and authority of your enterprise systems. So It's not that everything changes all the time, but because it wouldn't, right? It's things closer to the center change more slowly. Things on the periphery should change more flexibly. But if you don't have the capacity to make change, if you don't have the capacity to support variance, that's when you run into the problems that we have in the modern, enterprise stack, right? That's where, if you Google the phrase "enterprise software sucks," I think you'll find hundreds of thousands of responses for that, including several prominent analysts who have written treatises on why they're frustrated with their enterprise software. And what we're doing is providing a new kind of application framework that gives you the adaptability that you need to support what is, in fact, a more dynamic business climate, right? So the world is getting increasingly dynamic. We need application environments that can support that kind of dynamics, and that's what the problems we're aiming to solve.
Yeah, and let me throw a couple questions at you. We got a couple good ones from the audience and just a couple minutes left. You talked about how this is a combination of an engine. You've got this metadata layer that kind of drives everything, but there's a repository of all these objects, including data, of course, and UI objects and so forth. What is the data store underneath? Are you using a particular, like MySQL, or did you build something, or it just kind of depends? Can you tell us about the underpinning, like where the actual data and all this information you're showing is stored?
Oh, that's great question. Yeah, so it runs on, it's a data warehouse, a virtual warehouse or a virtual repository. So it runs as a file system inside any relational database. This is running on MySQL. Our customers tend to run it on Oracle or Microsoft SQL. It also runs on Postgres. It'll run on any of those. There is no database tuning required. There is no major configuration required. So it's actually very easy to deploy in any relational database. So relational database of choice, we find that when we go to an enterprise, they always have a preference, and we work with their preferences, right? We're trying to make them more flexible and adaptable. We're not trying to impose preferences. Actually, the only requirement of our technology, other than that you have a relational database, is that you have a Java servlet container, right? JBoss, Tomcat, Glassfish.
Okay, and one of the attendees is asking, in what form are data sets extracted when you're talking about grabbing actual tables, for example, or other traditional forms of data? How does the tool transform them? And I think you talked about how you can associate things instead of joining things, right?
Yeah, so it's that distinction between integration and connection versus binding and interoperability, right? So we make connections to any third-party systems, databases, devices, et cetera. And what we do is we create a RESTful adapter. That resource will be a piece of XML that describes semantic. It'll be a RESTful service, right? It'll be like an API that calls this third-party, whether it's a RESTful OAuth or whether it's a WSDL. It's going to actually contain the semantic for that. But by virtue of having that XML representation inside our system, it's just another resource in our system. Even though we're going to be calling that third-party device or application, we're storing the connection details to it inside a resource, an XML resource, which we version control and has all the other properties in their system. This way we can see every connection that system has to every other application inside our framework. We can see every performance of it. We know how fast it runs, how slow it runs. We can see every change to that interface as it changes over time. So for third-party devices, APIs, services, et cetera, we have an artifact, an XML artifact, that represents that connection. But once that connection is made once, then any application inside our system with permission can call it. Right, so we connect to iPhone, iOS once, and every application can call it. We connect to, Twitter, and instantly every application can call it. I don't know how much time we really have. I see we're running over, but I could actually show some of that, or I'll save that for anybody that is. I think my email was posted previously
Sure, and I will, even if not. Let me dig that up, and I'll push that slide again. So just a couple other questions from the audience. You said social media solutions. Have you actually got a client to do something with social media?
Yeah, we're working with people that are connecting through different profile management. They're going cloud-based profile management systems and social systems where people have like LinkedIn, where they're actually managing lots of aspects of their personal profiles are being managed out there, and they're being fed back into the system and correlated against other system objects, as it were. So yeah, we do have customers doing that, and I think what we're seeing is as customers become increasingly comfortable that are with the dynamics of our system and its capabilities, they're doing more and more dynamic things with it. They're pushing the envelope. So I'd say the customers are starting off more conservative, just doing more, incrementally more adaptive and dynamic applications, and then they're layering on more and more capabilities to them, which is another virtue of our system, right? Because it's all loosely coupled and late binding, it's very easy to iterate on applications in our system. You're not ever coding yourself into a corner, right? That's actually pretty expensive in SOA. There's a lot of governance and overhead that goes into managing, WSDLs, et cetera.
Yeah, of course. No, it's an interesting concept, coding yourself into a corner. I'm going to tweet that one as soon as I get a moment here. Let me throw a couple other questions at you real quick. How would you ever want to take some third-party data visualization tool and run it on top of this? In other words, could someone use Ideate as that sort of marshaling area and application integration and development environment, but once in a while pull out some stuff from your information warehouse into another tool, or even look at rules and how rules interconnect and interrelate? Is that something you would ever do?
Yeah, actually, we do it today. So we have connections to Pentaho to demonstrate things just like that. So I don't know if you're seeing my screen again.
Yes,
I do a quick. And this correlates to another question I saw that was posted as far as somebody, performance dependency on third-party systems, devices, and databases. The system, remember, the enterprise web resides as a file system inside that relational database. Everything that's local to that database will run, very quickly because it's all actually much faster than your conventional applications because we're not running in traditional ERDs, rigid structures, et cetera. Also, we're storing data code and UI all in one place. So things that are running local are, running very fast because it's associative, like a NoSQL database, but it's doing that all dynamically. But things that are running externally, like in this case, Pentaho. So I'm going to do an example of just a perfectly good use case. Like we don't want to be, a graphics tool, right? So if I come in here and I say I want to find everything for Bill Malik, and I find everything for Bill Malik pretty quickly, and there's some nice smart filters in here, and I go in here and I want to just find just a subset of records, and I'm going to push this out to an ad hoc quick report here, right? So this is actually pushing out to Pentaho right now. Pentaho is not tightly coupled to our system. It's not integrated. That took, 2 seconds? It generated, and I remember this is pushing back a PDF to me in this case. It could have been an interactive report. But it took the data off my screen, pushed it into Pentaho to generate a view, because we don't want to create bar charts and pie charts, right? And generated this multi-part report near instantaneously, right? So yes, of course, to the extent that that we're calling third-party systems because that's what people want to use, and third-party devices because that's helpful, and because they add value, and because they want to extend legacy, sure, there's of course going to be dependency, like in any distributed environment, on the performance of those third-party things. But then again, all of SOA is dependent on the same way. We're just less so because we're more capable at the center. We have less latency than your common middleware stack. Clearly, we'll still have dependencies where dependencies lie. They're third-party tools, and they could be adding some latency here and there. But because even then, when we're interacting with third-party tools, it's all RESTful, so it's just faster. And right now, there's a whole market for doing SOA, service, and API governance because managing services and APIs is very difficult. And in our system, you get that for free because we wrap every service and API with that RESTful wrapper, which allows us to manage its performance too. So you get a lot of side benefits here, right? So you can store things locally. The system will also do federated processing. In an individual transaction, in one single transaction, it could be doing a mix of local and federated processing in a secure way with referential integrity. And that's, again, if I were to push one slide, if I were to go back to one slide, I would say, what is, let's see.
I'll take it back. Hold on.
There's that one slide with that many. I think I can go back. I don't know if I'm showing it now. I don't know if I'm in control or not. But if you push that one slide of the many-to-many here, I think I might be.
I'll take back, and I think I can find it for you. Hold on. Like, do you see it now?
It's sort of that. It's going to be like a slide. It's going to be like 4 or 5 slides ahead of that.
This is your last slide right there.
The problem, it's back to that problem of dynamic and diverse inputs and outputs, right? And creating the thinnest middleware layer in between that to get out of people's way, right? There are still specialized utilities that you're going to want to use. There's still specialized devices that you're going to want to use. But if you can now do smarter applications that can be interconnected, that can be governed, that can be adaptable, if you could be now simulating applications in real time as you develop them, if you can get greater application durability, scalability, then I think we've done something of great value. You're not getting this out of your run-of-the-mill ESB. In fact, no ESB is doing this at this level. They're not offering full-on application modeling environments for complex process transformations and human-based processes, right? ESBs are really the domain of application integration from a systems perspective. So you have that divide again of ESB plus business process technology. That's the one. So there you go. So, I mean, this is the universe, right? As everybody's experiencing it today. This is the universe that people are struggling with. What we're saying is that you want to have the thinnest middle tier as possible because these are the things you value. You're distributed in diverse sources and you're distributed in diverse targets. And, we want to push our layer into the background, make it a utility that's just doing real-time transformation, real-time event-based transformation.
It is very interesting, and if I understand it correctly, I mean, really what you're trying to do, your long road or end game, I suppose, strategy here is to become that very flexible rules engine that, as you suggest, sits back behind a whole variety of different tools because you really want this to be the marshaling area for dynamic change, right?
Yes, exactly. So, I mean, what do you call it? I would call it more of a logical layer, right? Because it's truly logical. It's, if we go to computer science, this would be context-aware information system that's completely constraint-based. So, constraints, that's a fancy word for rules, right? So it just, goes back to what Robin was talking about earlier from an architectural perspective, separation of concern, decomposing rules and logic from data and code and UI, having all of those things exist loosely coupled in a single extensible layer that can include references to third-party devices, systems, and services and APIs, and then being able to run logic against it with a single object model, a single engine, in a single layer. That's power. And, hey, we're happy to go head-to-head on any dimension with any really other possible way to approach this. I mean, you can imagine how much it would cost to get IBM's Watson, and even that's not a process engine, right? That's still an analytics engine, and then you have to connect that, and I don't mean to name them specifically, or any other third-party kind of analytics, advanced analytics tool, and you think of the specialized databases those run on, let alone the kind of connection requirements you'd require for event processing, rule processing, business process processing, right? And that becomes a big mess. And that's very difficult for enterprises to manage. They're struggling today. And so we're trying to address those pain points. Not everybody's suffering from it at the same level, but if I put this in business terms, what business doesn't want to be more dynamic? What business doesn't want to be more adaptive? What business user doesn't want to have more personalized interactions, right? Everybody wants those things, right? They're just not getting them. And what we're doing is providing a new way of providing that that's lightweight, scalable, and cost-effective.
Yeah, well, great stuff, folks. We've gone a little bit long here, but wanted to get to some of those questions. You can see upcoming topics here, databases next month, and cloud innovators. And January, we're going to be focused on big data. Yes, indeed, it is the hot topic. Going to continue to be a hot topic for some time, I am quite sure. Big thank you to Dave Duggal from Consilience International, a.k.a. Ideate, and the Enterprise Web Concept. Very, very interesting stuff. Yes, folks, we will archive this webcast. Go to InsideAnalysis.com. Look under the Webcast section, and you'll find a link to recent episodes. And, boy, I think we've done 30 out of these things already this year, so we're definitely on a roll here, folks. And that's largely thanks to all of you out there and your great questions. So thank you so much once again for your time and attention. This does conclude our event. We'll catch up to you next week, folks. Until then, take care. Bye-bye.